We have given function and we need to find maximum, minimum and inflection points. So first, to find maximum and minimum, we have to find critical points. To find critical points, we need to find first derivative and set this first derivative to 0. So first, we will write the domain of our function. Y is all real numbers. Why? Because we have here the power, we have addition, subtraction, multiplication. We can add, subtract, multiply every real numbers. So that's why we have the domain all real numbers. Next, we need to find the first derivative. So derivative of negative 3 x to 4 is negative 3 times 4 times x to power 3 plus 4 times 3 times x to second power plus derivative of 6x squared is 6 times 2x. So this is equal negative 12x third plus 12x to second power plus 12x. Let me rewrite this. This is our first derivative, negative 12x to third plus 12x squared plus 12x. Next, we need to find critical values. So it means we have to solve equation y prime is equal 0 if and only if we have negative 12x to third plus 12x squared plus 12x is equal 0. So first I will factorize negative 12x. So we will have in parentheses x squared minus x minus 1. This is equal 0. When this left side will be 0, when this part, because we have multiplication, it means negative 12x will be 0, or x squared minus x minus 1 will be 0. The solution for this linear equation will be x equals 0, and we have quadratic equation. To find the roots, we will use formula x1, 2 is equal minus b minus square root of b squared minus 4ac over 2a. If someone forgot, a is coefficient before x squared, b is coefficient before x, and c is our constant. So in our case, a is equal 1, b is equal negative 1, and c is equal negative 1. So this is equal. Of course, I forgot to add plus, minus, because we have two solutions. So we have negative b, so it will be minus, b is negative 1, plus, minus, and we have square root b squared, so it's negative 1 to second power minus 4 times a is 1 times c is negative 1 over 2 times 1. So x 1, 2 is equal, negative and negative is positive. We have plus, minus, square root of negative 1 to second power is 1. Negative and negative give us positive, will be plus 4 over 2. So this is equal 1 plus minus square root of 5 over 2. So we have two solutions. One is x1 is equal 1 plus square root of 5 over 2. And the second is 1 minus square root of 5 over 2. We can use calculate and calculate this value. So it will be 1 plus square root of 5, this is equal, divide by 2. So we have approximately 1.6, and we have 1 minus square root of 5, this is equal, divide by 2, this is equal, negative 0.6 approximately. So we have 3 critical values. X equals 0, x equals 1.6, and x equals negative 0.6. Now, to find if we have minimum or maximum for these 3 critical values, we will draw the graph of our first derivative function. We just sketch this graph. We have the roots, so we have x-axis, we have 0, we have 1.6, and we have negative 0.6. We have know that the coefficient before the highest power is negative. It means we have to start to draw the graph from negative values, and because this roots repeats only one time, it means we just passed these points. Now we just check. When we are on the right side of 1.6, we see that we have negative values. This part is under x-axis. This part on the left side of 1.6 has positive values. This is negative, and this is positive because it's above. This is under, so we have negative values. Now we have to check on our number line. On the right side of 1.6, we have negative value because this part is under x-axis, and on the left side we have positive values. So when we change the sign from negative to positive, we have maximum. Now we have positive values and negative. So when we change from positive to negative, we have minimum. And again, we have negative values on the left side and positive on the right side. So we have maximum for negative 0.6. So now we have to calculate these values. So we have y of negative 0.6 is equal. We have to replace in our formula x's by negative 0.6. So we have negative 3 times negative 0.6 to 4th power plus 4 times negative 0.6 to 3rd power plus 6 times negative 0.6 to 2nd power. This is equal. We will use calculator. So let me write this. We have negative 3 times, open parenthesis, 0.6 negative, close parenthesis, to 4th power plus 4 times, in parenthesis we have 0.6 negative, close parenthesis, to 3rd power plus 6 times, and in parentheses we have negative 0.6 to 2nd power. This is equal 0.9. So we have maximum negative 0.6, 0.9. This is our maximum. Next, we will calculate minimum. Y of 0 is equal, we have to replace in our formula x's by 0. So we have negative 3 times 0 to power 4 plus 4 times 0 to power 3 plus 6 times 0 to second power. This is equal 0. So we have our minimum 0, 0. Have point of our minimum. Now we have to find the third point, y of 1.6. This is equal. We have to replace now x's by 1.6. So we have negative 3 times 1.6 to power 4 plus 4 times 1.6 to power 3 plus 6 times 1.6 to second power. This is equal. We'll use calculator. We have negative 3 times, and we have 1.6 to power 4 plus 4 times 1.6 to power 3 plus 6 times 1.6 to square. This is equal. We have 12.8 approximately. So we have our maximum point 1.6, 12.8. This is our maximum. Now we have to check if our function has inflection points. Let's use this space. So we need to find the second derivative first. So we have to find the derivative of our first derivative. This is our first derivative. So we have negative 12 times 3x squared plus 12 times 2x plus 12. So y this is equal negative 36x squared plus 24x plus 12. Now we have to set our second derivative to 0. Second derivative is equal 0 if and only if we have negative 36x squared plus 24x plus 12 is equal 0. First, I will divide every expression by 12. So it will be negative 3x squared plus 2x plus 1 equals 0. So again we use formula x12 is equal minus b plus minus square root of b squared minus 4ac over 2a. A is coefficient before x squared, b is coefficient before x, and c is our constant. So we have minus 2 plus minus square root of b squared is 2 to second power minus 4 times negative 3 times 1, is that we don't have to write, over 2 times negative 3. This is equal. We have x12 is equal minus 2 plus minus square root of 2 to second power is 4, minus and minus give me plus. 4 times 3 is 12. So 4 plus 12 is 16 over negative 6. So this is equals negative 2 plus minus square root of 16 is 4 over negative 6. So we have two roots. X1 is equal negative 2 plus 4 over negative 6, and x2 is equal negative 2 minus 4 over negative 6. So x1 is equal negative 2 plus 4 is 2 over negative 6 is negative 1/3, and x2 is equal negative 6 over negative 6 is 1. So we have two roots. To check if we have inflection points for these values, the easiest way is to draw the graph of our second derivative. We have quadratic function. We found the roots. We have negative 1/3 and 1. The parabola is up and down because we have negative coefficient before x squared. And we see when we passed 1, we change sign from negative values to positive because this part is under x-axis, so has negative values. This part is above, so has positive values, and this part is under x-axis, so has negative values. So at 1, we change values from negative to positive. So it means for x equals 1, we have inflection point, and for x equals negative 1/3, we change from positive values to negative values. So we have inflection point for x equals negative 1/3. Let's calculate these points. So for x equals 1, we have y of 1 is equal. It means we have to replace if in our function x's by 1. So will be negative 3 times 1 to power 4 plus 4 times 1 to power third plus 6 times 1 to second power. This is equal negative 3 plus 4 is 1 plus 6, 7. So we have first inflection point is 1, 7. This is our inflection point. And now we have to find value of y for negative 1/3. So now we have to replace x's by negative 1/3. So it will be negative 3 times 1 over negative 1/3 to power 4 plus 4 times negative 1/3 to third power plus 6 times negative 1/3 to second power. This is equal. We have negative 3 times negative 1/3 to fourth power is 1/81 plus we will have negative 1/3 to third power give us negative sign, so we have negative, and we have 4 will be 3 to third power will be 4 times 1/27 plus 6 times 1/9. This is equal. We can reduce 81 and 3 will be 27. Negative 1/27 minus 4/27 plus 6/9. Because we have subtraction and addition, we need the same denominator. So I multiply numerator and denominator by 3 to get 27. So we have, let me write this, negative 1/27 minus 4/27 is negative 5/27 plus 6 times 3 is 18/27. So 18 minus 5 is 13/27. So we have the second inflection point is negative 1/3, 13/27. This is our second inflection point. This is my solution.